On this example, we are trying to find all of the zeros of the polynomial function h of x equals negative 6x to the third minus 9x squared plus 60x. So the first thing is to see if we can factor this polynomial. It has three terms, but the degree is not squared, so we cannot use the AC method right now. But I do have a common factor. All of the terms are divisible by a 3. And since the leading term is negative, I'm going to factor out a negative 3. Also, all of the terms have an x. So when I factor out a negative 3x from each term, it's going to change the coefficients, and it's also going to reduce the powers of the x's, so that I get positive 2x squared plus 3x minus 20. Now 2x squared plus 3x minus 20 can be factored using the AC method. So the A number is 2 and the C number is negative 20. So 2 times negative 20 is negative 40. I'm going to look for two numbers whose product is negative 40 and whose sum is equal to the middle number 3. So to look at the combinations that multiplies to make negative 40, I can start with negative 1 times 40, negative 2 times 20, negative 4 times 10. I also have negative 5 times 8. Now if I search here, I could see that a sum of 3 is what I get when I add negative 5 and positive 8. So now what I'm going to do is I'm going to take that sum and I'm going to break apart the middle term 3x using the coefficients of negative 5 and 8 for the x. So I have, bringing this down, negative 3x, and then I'm breaking apart 2x squared minus 5x plus 8x minus 20. So if you add negative 5 and 8, you do get the positive 3 that we initially had. Since this has three terms, we factor by grouping. So we group since it has four terms, factor by grouping. 2x squared minus 5x plus 8x minus 20. Factor out an x, and you get 2x minus 5. Factor out a 4, and you get 2x minus 5. So bring down the GCF, negative 3x. Factor out the common group, which is the 2x minus 5 group. When that group is factored out, it leaves you with the coefficients which form another group, x plus 4. So this right here is completely factored. So I have negative 3x times 2x minus 5 times x plus 4. That is the factored expression for h of x. Now to find the zeros, we set each of these factors equal to 0. So I set negative 3x equal to 0, 2x minus 5, and x plus 4 equals 0. Solving for x gives me, when I divide by negative 3, I get 0. When I add 5 and divide by 2, I get positive 5 halves. And when I subtract 4, I get negative 4. Now the textbook may put the solutions in a set like this with rosters, but it's not necessary to do that. You can also just list these solutions separated like that.